Alright, today we're going to get into our next section here on exponential and logarithmic equations. We're going to focus today on exponential equations. So the essential question, how do we solve equations with variables in the exponent? Very important idea here, very applicable to lots of things in life and science. So it says questions are almost always given in the wrong form. So you're going to switch from if you have an exponential function, you're probably going to be switching it to log form. And if you have a log form, you're probably going to be switching it into an exponential function. Kind of just the way these work. It's always the wrong form. All right, remember your laws of logs if applicable. And then when you find x, plug it back in to make sure it does not make a log negative or 0, which would be an extraneous solution. So we are going to have some extraneous solutions only on the logarithmic equations, though. As you can see, everything on this page is all exponential equations to start. There are not going to be any extraneous solutions here because I can't make an original log 0 if there's no original logs. So I'm going to use logs along the way, but there's no original logs, so there's not going to be any extraneous solutions on these 4 problems. You can see that these are all calculator required, so you can get that ready. All right, so for number 1 here, we're going to isolate the exponential base. So I'm going to add this 5 over to the other side. And so we get 3 to the negative x equals 9. Now, this one you actually could, since these are, I can do this without logarithms. So there's 2 ways to do this one. I could just say over here, I could say 3 to the negative x equals 3 squared, since 9 is 3 squared. And so I could say negative x equals 2 and divide that by negative 1. So x equals negative 2. So that's one way to do it. Alternatively, if you really wanted to use logs, you could switch this now into log form, which would be log base 3 of 9 equals negative x. You could then use change of base formula that we learned last lesson. Log 9 over log 3 equals negative x. And then if you type that in your calculator, it would say 2 equals negative x, so then x equals negative 2 again. So however you wanted to do that one, that's fine. All right, now on number 2. Now we cannot do that trick on number 2 because I can't make these the same base, and so I'm going to have to use logs on this one. You can see the base is already isolated. My base is 10, so I'm going to say log base 10, and then remember that if it's a base 10, I'm actually not going to write the base, and so I'm just going to leave it. But inside the log is a 5 equals 4x minus 1. So this is nice because I don't have to use change of base formula. I always like to kind of isolate x first in terms of the log and then type it in the calculator. So I'm going to add 1 over. So this becomes log 5 plus 1. And technically I don't need that parentheses in the 5 because that plus 1 wouldn't be part of this anyway, but just to kind of emphasize that. And when I type in my calculator has parentheses inside the log, so I'm going to have the 5 in the parentheses, and then the 1 is not. And then I'm going to divide everything by 4. And so now I got my x isolated there. Now this is going to require extra parentheses up top when I type that in the calculator, because I got that adding or subtracting going on. So let's do that. And so when I type that in, I get that x equals 0.4247. So I usually like to go 4 digits on that. All right, next up here, number 3. So on this one, we're trying to isolate x. I see it is in an exponent on the denominator. So I'm going to have to use logs on this one, but just not right now. I don't like isolating things in the denominator. So my first step is going to be to multiply both sides by 1 minus e to the x. And so that'll cancel this out. So I get 4 equals. And over here, you can distribute that 15 in there. I actually don't like to do that. I like to leave it outside like this. And then I'm going to divide it back over to the other side. All right. I could get a decimal for that 4 over 15, but again, I don't really like to do that. I'm going to be typing this into a calculator in a minute anyway, so I'm just going to leave it like this. So equals 1 minus e to the power of x. Now I'm going to subtract the 1 over. Oh, and actually I'm going to subtract 15 over 15 on this side, since that's really 1. So that'll give me negative 11 over 15 equals negative e to the power of x. Divide that by negative 1. And we get 11 over 15. 11 over 15 equals e to the power of x. So now I've finally isolated my base. It did take me a while, and so now I'm ready to switch it into log form. So this is going to be a log base e, which is actually ln, remember? So ln of 11 over 15, excuse me, equals x. And so I don't need to change the base formula here. Because it's base e, I can just use my ln of 11 over 15. I'll get my decimal approximation here, which is negative 0.3102. Now, some of you may be thinking about extraneous solutions for that because it is negative, but remember, if I go back to the original equation, that negative is in an exponent, not a log. We are allowed to have negatives inside of an exponent, so that is fine that came out negative. All right, next up, number 4 here. So I'm going to isolate my base here. Looks like my base is e again. Remember, the base is not 4e. The base is just e in this case. That 4 has an exponent of 1. So I'm going to divide both sides by 4. So I get e to the 0.012t equals 2. And now we are going to switch it into log form. So once again here, we have a base of e, which is going to be our natural log, ln. And ln of, and the new partner will be 2. And then that's equal to 0.012t. And then I'm going to divide both sides by 0.012. Now my calculator is going to do parentheses around that 2, so I'm going to make sure I close that before I divide by 0.012. And this is going to give me a 57.7623. All right, we'll do one more here, number 5. So for this one, it's a little tricky, and you can see I only do this in my honors classes, is we have actually 2 bases here. We could, if a 3 has an exponent and 6 also has an exponent. So when this happens, we are going to switch it to log form, and we can actually just choose whichever base we want. So I'm going to go ahead and do this as a log base 3. And so we're going to do log base 3. And then the new partner is this whole thing, 6 to the power of x plus 2. And then that equals the old exponent of 3, which is 1 minus x. The next thing I would do is that we have this exponent, it's really inside of a log. So remember, according to our laws of logs, that can move out to the front of the log. Okay. And at this point, I would actually do the decimal I would do the log 6 over log 3. I think it's just going to be easier to work with for the rest of this problem if we get that decimal form, because we're going to distribute it back into that x plus 2. So that is 1.6309. We'll do 4 digits on that. And so I'm going to replace that here. 1.6309. And I'll distribute that back in. So that becomes 1.6309x plus, and then that times 2 would be 3.2619. All right, so now this is really just a linear equation. We have x's on both sides, so we're going to move all the x's to one side, all the numbers to another. So I'll add 1x over here, and I'll add a 1x over here. And I'll subtract 3.2619. And so on this side, that's going to give me 2.6309x. This will cancel. And over here, my x's cancel, but I'll have negative 2.2619. So now my last step is to divide the 2.6309 over to the other side. So negative 2.2619 divided by 2.6309. And we get our final answer here for x equals negative 0.8597. Now, once again, that is negative, but that's okay. Remember, the original is here as an exponential equation, so we don't have to worry about extraneous solutions. You can see down here, we're going to start switching into log equations next lesson, and for those, we will need to start worrying about extraneous solutions, so we'll get to that later.